All right, good morning. I'm going to go for the next word problem worksheet. We're going to have a total of 4 worksheets to do, and I'm going to have 3 due this week and only 1 due next week. That way it doesn't give you too much work all in the last week of school, which is only a 4-day week. And if you want to get them all done this week, you can, and not have any work for math in the last week so you can focus on your other classes. It's completely up to you. I'll put all the assignments on this week, allowing you to choose to do some this week and some next week. It's up to you. All right. So this is 2.5, age word problems. This is a worksheet that you will have in Google Classroom. And I am going to start with problem number 1. And problem number 1 has to do with today Selma is 5 times as old as Frank, but in 10 years she will be only 3 times as old. So when I look at this, trying to find one of my markers here. There it is. This is number 1. I'm going to make a table to make this much easier to do. And it's extremely important that you pay attention to how I do this, because it's going to make it much easier for you to do these problems. So we're talking about Selma and Frank. Now I'm going to make a table, and this table will have 2 rows and 2 columns. If there are more people that we're working with or things, then there will be more rows, but only 2 columns. The first column is the now column. And when you read it, it says today, meaning now, Selma is 5 times as old as Frank. Stop, and then it says in 10 years. Stop reading. Let's focus on the now. Selma is 5 times as old as Frank. So we don't know Frank, and we know that Selma is, because it's not talking about Frank, Selma is 5 times as old as Frank. Now the next category is in 10 years. What about in 10 years? In 10 years. Now it's either going to be in 10 years or 10 years ago, something like that. Now, if you're 15 now, how old will you be in 10 years? You'll be 25. So you're adding 10 to that amount. So I'm going to take their now age and add 10. Now I have their ages in 10 years. It says, when you read these, by the way, when it says in 10 years or 10 years ago, stop reading and fill in that section, because you'll be very tempted to use the information to set up the problem to fill these in. Don't do that. In 10 years, add 10 to the ages of what they are now. The next thing to do is to set up your equation. What about in 10 years? In 10 years, she will be 3 times as old as Frank. So she will be 3 times as old. Now we're talking Selma. Selma, the 5x plus 10. Will be is a form of is. That means your equal sign. 3 times as old as Frank is. 3 times x plus 10. So now we have to solve this equation. So we'll do that. 5x plus 10 equals 3x plus 30. I'm going to subtract 3x from both sides. and I get 2x plus 10 equals 30. Now I'm going to subtract the 10 from both sides. 2x equals 20. Well, gee, if 2x is 20, x must be 10. So now, probably the easiest place to put your answer is outside, but if you made a bigger section in your box, you could fill it in there. How old is Selma and how old is Frank at this time? How old are they now? Well, if Frank is 10, Selma would be 5 times that, 50. And that's how you solve it. Let's move on to problem number 3. I'm going to make a table for every one of these problems, and for some of the other worksheets, we'll also make tables. In this one, we're talking about 3 different people. And the people we're talking about here are Barbara, Matt, and Christy. Problem 3. So, all right. Now, didn't leave myself enough room up there. Could have made it a little shorter. All right, so right now it says Barbara is 6 years older than Matt and Christy is twice as old as Barbara. The one that doesn't say this person is Matt. So Matt is our X. Barbara is 6 years older, so X plus 6. And Christy is twice as old as Barbara. So if we double that, we get 2x plus 12. All right. The other category is 3 years ago. No, not ego, but ago. All right, so what about 3 years ago? If it's 3 years ago, that's in the past. So we have to back up 3. So we subtract 3 from each of these. So x plus 3, x minus 3, and 2x plus 9. Because I'm taking 3 away from the expression, that makes that 3. That makes it negative 3. And I have to take it away from the 12, not the 2. So 9. Next thing here is 3 years ago, the sum of these ages, not these, because we're talking about the 3 years ago time, the sum of their ages, so I'm going to add them up right here, 1, 2, 3, 4x, plus 3, negative 3, that cancels, plus 9 is 9, is 41, equals 41. So 4x plus 9 is 41. So I added up those 3 values, got 41. I'm going to subtract 9. 4x equals 32. And then I'm going to divide by 4. So x is 8. Find their present ages. So I can put it in here or out here. This time let's try putting it in here. If x is 8, then 8 plus 6 would be 14, and twice that, or 8 times 2 is 16 plus 12, 28. And those are their 3 ages. Can you see why, unless you had a really big opening here, it's easier to put the 14, 8, and 28 out here? All right, let's move on. Our next problem I'm going to do is number 6. All right, problem 6. What are we talking about? All right, this one's a little on the complicated side. We have building A, B, and C. I don't know why those all went uphill, but they did. All right. Now, here's where it gets confusing. It says building A was built 30 years before building B, and, still talking about building A, 20 years after building C. So, how do I set this up? How do I get the now part of it? How do I figure out the now part? Well, if we were looking on a number line, and this is the past, and this is now, I'm going to throw building A in there somewhere. I'm going to just put it here. A is there. A was built 30 years before building B. That's like I was born way before any of you. So building B is much closer to now. In fact, it's 30 years closer to now than building A is. And building A was built 20 years after C, making it not as old as C, so C's out here by 20 years. So if we were using building A as the variable, B is younger, so it's less than A, so x minus 30, and building C is older than A by 20 years. And that's how you would set up your example, your table of now. Now you could have chosen building B as your x, and that would change your values expressions for A and C, and it will give you different expressions here. And when you set up your equation, it'll be different than this setup. But an x will be different. But when you plug them back in, the result will be the same. I'm not going to spend the time to show you that. In 10 years. So that's adding 10. So see how adding 10 to this made it a negative 20 instead of negative 30, etc. Okay. So what about in 10 years? Let's see. Building C is building C, so x plus 30 will be 40 years younger than the combined ages of A and B. So I'm going to combine A and B. 40 younger than. So I have to take 40 away from A and B because those two are older than C by 40 years, so I have to take it away. Now I have to solve that equation, and let's do that. Let's see, x plus 30 equals 2x, 10 and negative 20 is negative 10, and negative 40 is negative 50. Let's keep that going. Let's see, how about subtract x from both sides? So 30 equals x minus 50, and then add 50 to both sides. X is 80. The question is, what is the present age of each building? So the present age of building A in years is 80, Building B is 80 minus 30, 50. And building C, 80 plus 20 is 100 years. And there's problem 6. Let's do our last example. I'm going to do the very last example on the page, number 10. This one actually involves inequalities and 3 different things. So we're talking about the ages of 3 companies. The oldest, this is number 10. Oldest, the middle company, and then the youngest. All right. And you'll see the same kind of trickiness in the other inequality problems, and we'll talk about how this works. The now category is still set up the same way. Sorry about the dishwasher running in the background there. The ratio of the ages of 3 companies is 2 to 4 to 5. Now, when you talk ratio, you're talking about things that are done in proportion to each other. For example, if you were making a recipe and it called for 2 eggs, a cup of sugar, and 3 cups of flour, then if you doubled it, you double each of those values. So, this case, they said that the youngest is 2, the middle is 4, the oldest is 5 in ratio. So we do 2x, because we don't know what we're multiplying by, 4x and 5x. That keeps them in the same ratio. And you'll see that same type of hint in the other example, number 9. 20 years ago, so I'm taking 20 away. Notice as soon as I read that, I don't look at the problem anymore, and